Here's our fourth example for multiplying monomials across polynomials, single terms across multiple terms. Notice on this problem we have 5x times the quantity 2x squared minus 3xy plus 4y squared minus 3x times the quantity 4x squared minus 2xy plus y squared. So we first start off with this distribution of the 5x. 5 times 2 would be 10. X squared, common bases, we become x cubed. For the second part of our distribution, 5 times negative 3 is negative 15. X would be x squared. The y comes along for the ride. And finally, for this first distribution, we would have 5 times 4, which is 20, x, and then y squared. Again, we tend to have our variables in alphabetical order, and we do like to write them from the most powerful to the least powerful, descending order. I move to the second part. I need to distribute a minus 3x, and so I distribute this across the polynomial. Negative 3 times 4 is negative 12. X squared would be an x cubed. Go to the second part. Negative 3 times negative 2 would be a positive 6. X would be x squared, and then I bring the y straight down. And finally, a negative 3 times a positive 1 would be minus 3. X and y squared. As I look at these 6 terms, I then want to find any common terms, any like labels. And so I notice that the leading one here and the leading one here both have the x cubed, so it must be the same type of term. 10x cubed minus 12x cubed would be a negative 2x cubed. When adding and subtracting, you don't change the label. We're just recombining our like terms. In a similar way, I look at the second term. I've got this x squared y, and I've got an x squared y here. This is negative 15 plus 6. So negative 15 plus 6 would be negative 9 x squared y. And once again, like a broken record, x squared y's, when you add and subtract them, that won't change that label. And finally, we look at these terms that are not underlined. We have a 20xy squared and a minus 3xy squared. So 20, take away 3, would be plus 17xy squared. There we have 4 examples of how to multiply a monomial across a polynomial.